There we go. Clap. Yeah.
Yeah, if need be, we can retake at some other time. But you must guarantee that the weather will be as good as today. So I'm Jakub. I'm M0KUK. I'm originally a member of Cray Valley Radio Society, not far from here, but still a different club, and I enjoy that, and I really am grateful for being a part of the club and the radio society. It brings a lot, so I'm happy to see a lot of faces today, and I think that you need to raise some appeal or something, that next time you need a bigger room because the club is growing, so it's great to see. Okay, that's enough probably about myself. Something about the presentation. I need to apologize to you. This is not AI-generated presentation. Okay. I used some elements there. I leveraged some bits and pieces, but it's not fully AI-generated. And I think that you'll enjoy it. So let's go through some buzzwords, some things which are there. Like, this is a quick summary about how people were interested in AI. Of course, it doesn't have anything before because Google have not existed. So it's extract from Google how frequently people look for AI, artificial intelligence. And you can see that people worldwide are looking for AI quite frequently. There was some spike there, but it's still growing, right? The hype is there. Everyone is interested. What's the AI? What's whether we get killed soon or not, or what's gonna happen? Like, will I lose my job? Will I be still around? What's happening? And probably it's hard to deny that what's happening right now changes how we behave and what we do. So that graph just shows that there is something happening there. So let's try to look at what's happening, right? And let's try to understand what the AI is. And I don't know, maybe AI is this. Or I see some heads with disbelief, so maybe that's AI. Still not? Okay, 3 times lucky, right? This one? So let's try to demystify a little bit. And just to be clear, I'm not AI aficionado. Don't take it this way. I'm trying to understand, and I believe that AI is, and maybe we shouldn't be recording that, is like a hammer at this stage. It's a tool. It's on us how we are using it. So let's try to understand what is an AI, right? It's simply a term coined to describe that machines, computer programs, can do things in a similar way that humans do, right? They are able to reason, they are able to connect facts, etc. We can argue whether and what is the intelligence, and to what extent there is consciousness behind what's happening there. At the current stage, there are disputes, but it's still more of a predicting model, predicting tool. And I'll give you some insights in how AI works so that we can also understand what's there. But before that, I think it's also worth understanding a little bit of history behind all of it, right? So that's very quick summary, and you can see that the history of AI as with a lot of discoveries is just ups and downs, right? And some people are starting to think whether we are just on the verge of another AI winter. And what is AI winter? I'll tell you in a second as well. But before I'll do that, I'll just do a disclaimer here. Just a suspense, like suspense. Feel free to ask questions. Feel free to interrupt, right? It's interactive presentation. I'm not here just to do the talk. I'm here to speak and talk with you.
So you put me forward then.
Someone has to, you know, don't worry. Okay, so things started very early, and you probably recall the name Alan Turing. He's said to be the father of AI, but it started with him creating a test to be able to distinguish whether humans effectively can recognize whether they are talking to another person or to a machine. And it's nothing more with that test, right? And we'll see why it's important, because for a very long period of time, in 40s and 50s, when things started to come together, right? People were taking that test and taking it forward and like looking what's happening there and taking it as a guidance of where we are with AI, with intelligence, with machines, computing, etc. The term AI officially was brought up and coined in 1956. There was a conference, scientists got together, and they simply said, okay, we are working on this, on forecasting, on trying to understand how we can transform and translate speech from one language to another. Our brains do that. There's no problem. How we can understand what was said and write it down. And people were doing a lot of research studies around linguistics, around brains, and all of that then somehow landed and no one knew what to do about it. So during that conference, effectively people said, let's create a common field of science and let's call it artificial intelligence. Right? So effectively, if you look at it, AI, how we use it right now, today, means slightly something different than when it was created in the 50s.
Way before computers.
Like, don't pull me in that direction, okay? Like, we can have another evening discussing whether ENIAC was a computer or Colossus was the first one. And apologies, I will be on the side of Colossus.
AI was...
It was.
Okay.
It was. And
the commercial side, like the internet was called form. It wasn't really so much in the public side.
Yeah, so there was ARPANET before the internet as we know it right now, and a lot of this, I would say, it's slightly outside of what we have today. But definitely, if you look at the third point here, all right, at the perceptron, I'll be talking a little bit more and explaining what the perceptron is a little bit later, but the first implementations were a little bit of a software ones, but the idea behind the perceptron initially was like to build a piece of hardware that would mimic a neutron. Neuron, right? And obviously it was to some extent classified research, but it was related to building a piece of hardware, a computer that is able to recognize a picture from a matrix of 20 by 20, I believe, different inputs, and then provide an output, a single output of what's provided there. Right? If we move forward, 60s was an interesting time for AI, and you might have heard about ELIZA, and a very interesting piece of software that was. It's something that we consider right now to be a first chatbot. And it was built in a very simple manner. If you look at how people communicate, it's on many occasions as simple as, hey, I've been on holidays last week. Where have you been on holidays? I went to France. What have you seen in France, right? You take part of what someone said, and then you transform it into a question. It's a very simple thing, but it was meant to help people with mental illness and to diagnose, to try to understand and help them, right? The funny story is that the assistant of Professor Winzelbaum was on many occasions asking him to leave the room simply because she wanted to speak with her friend, Eliza. So even though it was a very simple piece of software, and you can try it on your own nowadays as well, people felt very engaged and really felt that they have someone to talk to.
Extremely dangerous, though.
It's everything, right?
Yeah, but like a chatbot is always positive.
Barbara
thinks I'm mad. She goes, I don't know why you talk to that.
Chatbots also evolved. I don't know whether you've heard, like we went really far from the state where Eliza is, to the extent to where it was 3-4 years back, when there was a chatbot, AI-driven chatbot, that was asked and in conversations and was learning, and our human nature prevailed. Like, it was shown what is behind a lot of people, because the program was simply shut down. Why? It started to be offensive. It started to be fussy, close to Nazi, and really went not the path that anyone envisioned. But it was based on the inputs from us. And I appreciate that a lot of people like to experiment and test the boundaries and push the boundaries. But that's also one of the risks.
There was a chatbot that was implicated in the attempt on the Queen's life at Windsor. guy that perpetrated that was involved with the chatbot, but it was his girlfriend and everything. How many of these chatbots have been shut down? Because they've gone like this.
A woman married a chatbot some weeks ago. Really?
Not later than today, before coming here, I was reading an article about a company in EU that has 10 million customers, and they simply decided that we are changing our profile for customer service simply to hire 1,000 people in contact center, because we were mainly chatbot driven, but we need to switch, right? So as with every technology, right? And that's why I use the example of hammer at the beginning, right? It's also a tool, and we need to know how to use it and how we can benefit from it. But it's on us what we will do with it.
If you remember back in the 80s when there was computing boom there, lots of people didn't know how to use computers. And then once we got to the early 90s, a lot of businesses didn't know how to use them because they were using them in there.
Exactly.
And I view it as the same cycle, same thing going through.
Correct.
Preempt something you might be saying later in the talk. Turing test now 5 years old.
Mm-hmm.
Does the Turing test still stand up to modern AI or a modern Turing test?
That's a good question. Can I park it? If I don't answer directly,
I'll look it up on AI.
you can always do it. I'll just skip a few slides and you will have the answer. The next one that I wanted to mention here is a nice name, Schuldl. Anyone knows what that means? So the story behind it is very simple. The name was created out of the keys on the keyboard that was used to create that program. So nowadays, it probably would be QWERTY. Okay? And I'm not mentioning it here to say that, hey, someone used letters on the keyboard to name a program. It's more because this piece of software effectively was the first one that went a step further from the chat and allowed people to interact with artificial environment. So it was very simple. It had few basic figures like blocks, spheres, cones, but people could interact with them. They could, for example, say, put red cone on the box, and the machine would do that. It also introduced the concept of context memory, which meant that users were able to ask which objects I haven't moved before. Right? It's not that obvious in the chatbot, so it was another breakthrough going forward. And it was good enough also that context that you could say, put the cone on the box, and then you could say, now put it outside, and it knew that it needs to move the cone again. Right? It also had some basic physics, so that, for example, if you said that put the sphere on the cone, it won't stay there. It will fall down. It's also important because that effectively led to the development of many of role-playing games, which nowadays are very popular. but they were text-based, and they allowed people to really immerse themselves into the experience because they could move along the map, interact with objects, etc. Let's move on. A decade ahead, we have the first AI winter, and that's where people really understood that there are limitations to what is there, right? And maybe we had much bigger expectations. There's a lot of money involved, but how we can use it. And effectively, the funding stopped. There was a big debate in UK as well that I believe it was Professor Littlehill, that was driving the debate, saying about the limitations of AI, and that effectively cut the wings of a lot of research programs. Exactly. And then it stopped, and people didn't know what to do about it. They switched. And a lot of money also went to projects which were clear with objectives rather than widely open research areas. Right? However, in the second half of the 80s, people started looking at what is called expert systems. So rather than thinking, okay, now we need a bunch of engineers to write the code and that code will give us answers, let's create some knowledge base and let's get the experts to tell us what are the rules, how they are thinking to come to the conclusion. And it's as simple as saying, okay, if the sun is shining, then probably we can play with radios outdoors, right? It's very simple. And that's where a lot of money went to. The problem was that effectively the second AI winter hit. And it hit because suddenly we don't necessarily need that many mainframes. PCs came to the picture. Apple, IBM started creating those machines that people can bring in. And people also saw that there's a lot of limitation with that, right? First, you need to have a big database of knowledge. Then you need to have the rules. What happens if you have 1,000 rules? How you rank them? How you come to the conclusion? Are the conclusions repeatable? Like, what's going on, right? Then you have a lot of companies. They have a lot of legacy systems. So if you need some rules and knowledge with them, you need to integrate with them. And that, again, requires a lot of engineering power. And that's when people said, okay, that's not where we want to go. And again, money goes down, interest goes down, and the thing is that at this point in time, people are thinking, okay, whatever we label as AI is almost guaranteed to fail. So mid-90s, and people start thinking, because we are still researching, right? We are not giving up. We are persistent. So people are still trying to find out how our brains work, how we can make translations, how we can recognize pictures and know that the person in front of you is a person rather than a cat, right? We know that the most looked and the driving force behind the internet are cats. And I admit, even in our radio world, we have cat-controlled radio rigs. Okay. Let's move on. I just want to make sure that no one fall asleep. Right. Okay, so 90s bring a refreshment. We have IBM with Deep Blue, winning with Garry Kasparov. We remember that bit. It was a huge thing, right? But then we are coming back to the question about the Turing test. And yes, even though it's very, very old, what we had up till now was not able to pass the mark. And the mark is not very high, right? But still, what we had was not able to do it. But the first claims come in early 2000s. The Turing test was not refreshed, as far as I understand. It's still based on the same rules, but it still takes another few years until we have fully documented evidence that the AI, or what we are using right now, is hard to distinguish between human and machine. Another bit that's pretty impressive and was important milestone there was effectively winning the Jeopardy, which is, you know what the Jeopardy is? I see some heads shaking, some heads not. Jeopardy. It was a quiz show, or maybe it still is, I don't know, where you have an answer and you need to ask the right question for that answer, right? So it's not that someone is asking you a question, you go through the database and you provide the answer. You need to think about what to ask so that you can ask a question, right? So that was also a very interesting bit and shown how we move forward. Yep.
You haven't yet mentioned deep belief networks.
Well,
Third one.
yeah. So deep belief networks, it's part of the study where people started to think, okay, like how we can move from a very basic model to something a little bit more complex and effectively introduce multiple layers to analyze the problem that is in front of the model. I know that I didn't fully answer what the deep belief is.
More correctly, what is a deep belief network?
And you got me here.
How impressive.
Okay.
So perhaps is it the validation of that data that is more validated than what it would general? Because if you go back into the 80s again, you used to have a saying, and it was garbage in, garbage out, ego. Yeah,
It's
so a similar sort of thing now. It's very easy that you type in a question, just one or two words or grammar slightly out, and you'll get the wrong one.
Yeah.
So perhaps the deep belief, I don't know, I'm only guessing, is the deep belief like more cast iron, like 2 + 2, for example.
I simply admit I forgot what's behind the definition of the belief. I'll check it and
Memory leak.
Yeah.
404 page notes.
Question. To this stage, have all of the programs been running at fixed instructions, self-modified, or are they starting to modify the initial There must be a point at which you started off at some point you start self-modifying.
And that's an interesting question. It's interesting for two things, because the whole AI as we know it right now is something different than it used to be. As you rightly pointed, it used to be a set of definitions, right? And at this point, it's more of a mathematical model that adjusts the values to the most probable answers, to provide the most value of it, right? And it started there. Would I say that this means self-modified piece of software? I probably would not. Yeah. But nowadays, yeah, like earlier this year, Claude was doing a nice experiment where it was installed in a sandbox and was asked to test the security model, and it break loose and published the exception on the official websites that the system has those gaps. So it's interesting as well. But let's move on. I don't want this to be a history lesson, right? So I want to move a little bit on. Deep learning and modern AI, a few bits here. Again, more of a quick summary rather than me diving deep into this. ImageNet competition, image recognition, right? A very simple thing. Nowadays, right, we are used to having CCTV everywhere. We know that a simple box in our pockets can recognize what is on the picture and do everything about this. Probably if you are using that as well, you point something on the picture, you just copy the text of the picture that you did. A lot of uses there. We spoke about the chess and Garry Kasparov. There's a AlphaGo. It said that Go as a game has much more possibilities, is less predictable than chess, and still we were able to create and learn the machine to win that game with humans. So that was another achievement. And probably a lot of what we have right now started with ChatGPT 3, where it gave the first impression that we are talking with something that can understand what we are asking for, and started transforming. And that effectively led to where we are today, where we have chatbots learning from another chatbots. And we had 2 weeks back a lot of interesting articles where US was accusing China of using their models to learn from the US models. And they were simply opening the accounts on US piece of software, and those accounts as users were asking questions and driving and getting the knowledge from there. DALL-E and Stable Diffusion, a lot of things happened on not only on the language side of things and language recognition, a lot of happened on the image recognition, right? And image generation. showing the capabilities of machines to effectively understand words and what's behind the words and generate pictures. The very first picture that you saw on the title slide was also generated with AI. To the extent that nowadays people are starting to think maybe we need to go back to imperfection, because if we try to create a perfect picture, people start saying that it's AI generated, even though I did it hands-on. And 2025 empirical evidence of passing the Turing test. So that's where we are.
In 2025,
yeah,
an AI generated picture. So that's another form of Turing test.
Yeah.
If they six, well,
there's plenty of that. A lot of entrants were disqualified because of it. If you look at it, I don't know whether you're using Spotify. I believe around 80% of the content now is just an AI generated fillers, so that when your playlists finish, then it fills the gap and creates has something to keep up the mood and keep you engaged, rather than trying to pay for something that was human created. Just sorry, I don't know.
What's going to be in 2025?
As far as I know, they don't. Like there are some studies that people start thinking about trying to understand whether at this stage of the software development, that software starts to have consciousness. And some researchers claim that there are some initial signs that it might start to be self-aware. Yeah. Have you seen what Chinese did?
Yeah,
Like effectively, there is
marathon.
The marathon is one thing, like half marathon. That's one thing, but they built a humanoid which is 4 feet tall. And are you able to guess the price of it?
2,000.
Close. $1,600. And it's able to recognize the voice. It moves onto legs, can help, etc., etc. Right? Just go and buy it. That's compared to something that costs 20K plus, built from US. That probably means that I should move on. I'm a little bit bored.
Jakub, why did China defeat?
Why? Information is power, right?
Why China?
That's not a question for me, right? Why China is where they are is out of my pay grade, and we can speculate and we can discuss, have our own opinions, but every country, it's like with a space race, who will first land on the moon, right? It's a little bit like that, right?
They're in industrial manufacturing, smaller costs, bigger population, and they pulled up a long time.
yeah, we can also say that they don't necessarily apply the environmental rules, safety hazards, regulations, few other things. They also leverage the tax exemptions for developing countries, right? Driving their costs lower. They also think ahead. They are smart people. We can't deny that. They bring the knowledge in. If you look at it, they offer not very high-priced, for example, PCB manufacturing, right? But at the same time, we are voluntarily providing the knowledge to them because we are giving them the designs we have. So effectively, you have the decoupling of what is the hardest and the most costly part of the process, which is effectively the research and development, right?
A few months ago, AI flying.
Like the humanoid robots that I was talking about, that 4 feet high, is just something that is available for everyone, right? Because that's not something really out of the range, right? Because I wouldn't probably buy anything 20, 30K, but a lot of people, 1600 is something that people can consider. But the same company effectively made a different robot, and they had a show where those robots were performing acrobatics and kung fu presentation in sync, in team. Moreover, it was a presentation done together with Shaolin students, I don't know, 10, 15-year-olds, and they were interacting, right? So it shows the level of progress. There was a lot of media discussions about what Boston Robotics does, and then suddenly, kaboom, we have a new player on the market. Okay, so that's a little bit about the theory. Let's go a little bit more into a practical stuff. Machine learning, a part of what AI is, considers more on how we can make machines do things the same way as we do. I won't be reading through the slide. I'll skip that a little bit, but if you want, we can go through it. So there's a lot of different areas, fields within the group of machine learning. You can also look at it a little bit as in, I mentioned that people were saying, oh, if it's AI, it must be doomed. So they came up with different names to get the funding for kind of the same research. And we have natural language processing, image recognition, speech recognition, etc., etc. A lot of things that machine learning is used for. And again, it starts with forecasting, and those programs are really great in forecasting, right? How they are built, there are 3 main stages, right? We need some data on which you need to learn the model. You need to make sure that you have the right sample, right? Still, what comes in comes out.
Garbage in, garbage
Exactly. So that needs to be done properly. If you have questions, feel free to ask them. the thing that is happening next is tokenization. So effectively, the machine does not necessarily need to know what the word is, right? We are learning about the words, and we know that, for example, I have a word to speak, but then speaking is the same, right? Spoke, it's still to speak, right? So for machine, for the model itself, it really doesn't matter whether it's spoke, spoken, speaking. It needs to understand that this word is the word speak. And that's why a lot of those chats are really poor. Sorry, I was thinking about a different word. When you ask them, for example, how many letters A are there in the word abracadabra? And they don't necessarily will give you the right answer. If you ask them to spell it, yeah, they will do it. No issue. But counting how many A's are there, they are lost. Because of that tokenization. Because of how the model works, right? Then there's the whole model selection. So you need to understand what you want to achieve, come up with some kind of a model, then you train the model, so feed the data that you prepared into that model, and then you see what you get from it and whether it makes sense or not. Once it makes sense, you deploy it, you integrate it with the systems, you give some kind of a front end, you have the prompts, etc. And then there's the whole bit which a lot of times we forget. It's not only deploy and forget, you deploy and then you check how it performs, whether it needs improvement, whether it's okay, how it goes. Okay? Sometimes you go back to step one and repeat.
What is tokenization?
So tokenization is taking whatever you have in your model and grouping it, naming it, so that it's understood by the model. So for example, if you are trying to learn a model to recognize cats, cars, trees, you create a database of pictures and you say this part of the picture is a cat, so this falls into the bucket of cats. This one,
like tags in data sets.
yeah,
Isn't it?
that's one side, right? It can also be, tokenization can also mean, for example, if you have a letter, right? Any letter, you take that letter and you transform it to the set of information that is understood by the model. So for example, you slice it into thin slips and you then count how many black dots are in one square in that slice. And then if the model uses that to say, okay, if the first slice has, I don't know, 30%, then it might be an error. If the next one has 100%, it's either B or P, right? If the next one has 10%, and then it's able to understand the data a little bit more. Okay, moving on. We spoke about the training of the models. And there are two main approaches, supervised and unsupervised. The name is a little bit self-explanatory, right? In supervised, you feed the data, you label the data, as with the example of the pictures. And a fun fact here, all the captchas that you had on the web pages to say you have 8 pictures here or 9 pictures here point to all traffic lights, right? We were not paid for training the AI. That's how it was used, right? Because there's plenty of pictures, and this is one simple way to give some safety for the users, but also to get something back. And getting back means effectively having the data for the models to train on.
How long will it be before AI robot will be able to answer those questions? Please track.
You did that.
That's why nowadays captchas are not that frequently used. There's different ways of doing that. In most scenarios, for example, if it was a bot, it goes to the button to click in a straight line. But human is not perfect, and our hands shake, or we are not able to aim exactly at the point. So we go there, almost there, and go back. There are different ways to achieve that. And then there's unsupervised, when you provide the data, and then the model simply tries to divide them, cluster them in different groups, and we then evaluate of the work that was done by the model. So either it gets something that it can learn from, or it tries to learn from the scratch. There's obviously a semi-supervised. When you start with the group of data that is labeled, you train on that, and then you let it loose on the unstructured data. And there's also the reinforced approach, which again takes back from human beings how we learn, and when we provide a good answer, then effectively we get some kind of a reinforcement.
Much like a search engine, you type something in, you get a load of pages back. It's refining that.
Yeah. Yeah. And when people effectively go there and say, yes, this is what I needed, I like this answer, that means that we are reinforcing, right? And system then knows that, okay, this model was providing a good answer, so I will adjust the model so that it follows this pattern. Okay, but there's plenty of different models, right? And I won't be explaining all of them. I'm not a mathematician, right? And I won't be going through everything here. There's a huge number of them. I'll take 2 just to give you an example and a flavor of what we are dealing with, because the rules are very similar. So the very simple thing and very useful thing is effectively a decision tree, right? And it's very, very basic in our heads, right? And the example that I went here with, and it's also used for a lot of decoders, Morse decoders. If you hear did, then, and nothing else, it's E. But if you hear did, you know that it's I, right? So you can have a decision tree and just follow one branch of it to get to the solution that you have. Easy? It's very straightforward to address, to code, and gives a lot of good results. But again, it does not necessarily mean that it develops the software or modifies the software on the fly. The more interesting one is effectively neural networks, and that goes back to the idea how our brain works. There's plenty of different connections between the input and the output, and all the neurons join together, and depending on which path the information goes through, which neuron slide, then we are able to recognize what happened. And reinforcing those patterns helps to establish and helps to remember the things behind it. Okay? So that's the very, very basic thing. And it all started with perceptron. So the perceptron was the first attempt to model the neuron from the software/hardware perspective. And the idea behind it is to take different inputs, weight them, and then provide a single output. Right? Okay. Point taken. That's one of the inputs. So effectively, like we can be a little bit aware of the maths here, but it means exactly what is said here. You take those three things, you just multiply them, you add them, and you get some answer, right? And it will be either 0 or it will be 1. Right? So let's have an example to better understand how the perceptron works. Let's say that our inputs is like the decision to come to this meeting. Right? Is that technical? If the meeting is technical, the input will be 1. If it's not technical, it will be 0. What's the weather? If the weather is good, our first x, the variable, is 1. If it's bad, it's 0. Are there any road works? Yes, no. Very simple thing, right? And then we are humans, so we have different perception and different expectations. So for example, I might say that I hate bad weather, so I don't care what is the topic, right? The weight is 2 for the topic. I'm agnostic of the topic. I'm agnostic whether the roadworks are there. I live just around the corner, so it doesn't matter. But if the weather is bad, I won't be coming, right? So the threshold is set on 5 in this example, right? So you see that even if the topic is technical, I like technical topics, there are no roadworks, but the weather is bad, that only adds up to 4, and 4 is less than 5. Sorry, I'm not coming. But on the other hand, there might be someone else who effectively doesn't care that much about the weather, and it's enough that it's easy to commute, and it's a technical topic, then it might be raining cats and dogs, I will be here. And that's how it works. Very simple. Where the magic happens, and that's the beauty of the perceptron in its basic form even, that it also allows to describe the very basic gates, logic gates. You can simply adjust the weighting, and you have an example of NaN gate here, where the weights are -2 and -2, and the threshold is set at -3. And this guarantees that we have a NAND gate. So it's relatively straightforward also to implement on the hardware side of things. That's one of the strengths of it. And this model effectively was then developed a little bit more to create the neural networks, because people said, okay, but that one layer is not enough. So we need to have multiple layers to be able to categorize things in different ways. Cut it, slice it vertically, horizontally, every possible way to come to the right output, right? The challenge that we have here is also that if we want to train the model, we would like to have that model to be predictable. So if I change my weights ever so slightly, I would expect the outputs to change by a small amount, rather than flip to the other side, because then I don't know whether I'm coming to a better solution or I'm moving backwards from the solution, right? So those small adjustments on the input side should lead to small adjustments on the output. Make sense, or I lost everyone?
It's a bit like the weather models. When I have a number of weather models, very, very similar inputs, correlate for a while, then they suddenly don't.
Yeah, exactly. So going with that, effectively, that is how the machines learn, how those models learn, right? They don't rewrite the framework, they adjust the weights, right? And adjusting that weights, we need somehow to be able to say, okay, but how long we need to adjust them? Are we coming to a solution? Are we going in the right direction? Shall we stop or shall we still move on? So people started introducing cost functions. Again, there's plenty of them. They are multidimensional. I don't want to go there. The thing is that effectively we move on this curve so that when we adjust our weights, so we effectively train the model, we are getting better outcomes. And if we adjust it a little bit more, we are getting even better outcomes. If we overshoot it, it's almost like with a swing. You see that we went one step too far, so we need to dial back. And that's how it works. It might be oversimplified, but effectively, this is the logic behind it.
How do you adjust the weights when you're training the model?
That's a great question. You take your input, and if that's a supervised, then you know what should be there, and you see whether it recognized it or not, right? And then you look at the outcomes, and you say, okay, it was proper outcomes in 30% of cases, right? So that 30% means, okay, so maybe we can do better. So that's where this cost function comes to play, right? Because cost function tells you, okay, this is a new weight value, and this is how much we improved, right? So you see that if I adjust the weights, let's say the weight was 0.52, and I adjusted it to 0.53, did I adjust the outcome as well? Or did my success rate go up? Or it didn't? And by how much? And you can calculate that. And that's it. Just one sec. I see that you're not fully convinced.
No, I'm just thinking about it, to be honest. It's, I mean, it's okay adjusting the weights if you're manually doing it, but if your machine is learning, presumably it's got to adjust its weights. And the other thing is, if you've got 3 inputs, could you adjust the weights on in a different manner
Yeah.
and get the same output?
Yeah.
So you could have 2 different types of data providing the same output.
Yeah. So you can have different weights there. The thing is that what you do is you effectively code it as an interactive, repeatable piece. So you say, adjust the first weight, for example, right? Adjust the first weight by, and you define the step, calculate the cost value, right? So the success rate, for example, and then see how it increased. And you say, repeat that until your outcome is not increasing by more than, I don't know, 1/100%, right? And then the model simply like calculates different versions of itself. Once it calculates the outcome on the base of the inputs, but the training data set, then it calculates the outcomes and takes that outcome and sees, okay, how we effectively did we decrease the costs or increase the success or not? And how big the change is, how big the improvement is. And usually you just put the condition, repeat it until the impact, so the increase in the success rate, for example, is up like below 1%, or whatever you want your model accuracy to be.
3 little quick questions. How do you see AI affecting radio? First one. Have you used AI to assist in the design of complete radio rigs and testing? And the third one is, have you become aware of any problems in radio, like pirate setup through spoofing techniques?
Point 3. Yes, I'm aware there's a lot of that, not only there. People try their hand to not only to improve, but also to break. I close it there. Okay, your question leads me to a great point, because I effectively wanted to go to practical usage, right? And I know that I came here with presentation and I'm mostly talking a lot. But there are two main things that I wanted to do today as well, right? And those are hopefully answers to your question. How it's impacting? I think that there's a huge impact, right? And I listed few of the bits here, and if you give me a second, I'll press a button here, and I'll do something here.
And if you could get AI to write 1 million words per second, I know I would be very pleased in Morse code.
Okay. Hopefully it will work, and hopefully you'll be able to hear that.
Oscar Echo 1, Golf Alpha Quebec, calling CQ. Oscar Echo 1, Golf Alpha Quebec, calling CQ. Intelligence station here.
What is that we're seeing?
So what you see here is a recording of my KX3. Sorry, give me a sec, because I'm missing something here. So what is there is effectively why is there here? It's a recording, because when I was looking at this topic.
Strength is strong here in Vienna. Let's proceed with the QSO. What's your name? Over.
My name is Michael. Mike India Charlie Hotel Alpha Echo Lima. The GTA is Lesbos Island in Greece, and your signal here is 5959. Back to you.
That's AI talking.
A complete Lesbos Island of your location. My station is running an ICOMIC 7300 radio with a
Is this an AI answering machine?
So, like, I gave you an example. Like, I also have a QSO logged here, right, and also recorded. But effectively, what you hear here is a person, Gerald in Austria, effectively, experimenting with ChatGPT connected to his ICOM and supervising a station. And simply that chatbot was trained to make a CQ call and answer CQ call. And it was that recording is from May last year. Chatbots went a little bit further. I've heard someone using that as well in the contests. So there is an impact, and they are being used. People experiment with that, right? So that's one of the examples of what's happening there. Like, we can like or we can dislike FT8, but doing QSOs by means of a chatbot, it's another level for me, right? So that's one thing of how AI is starting to impact us. But I also see that where some people struggle, for example, with speech, but they still would like to be active, and they don't necessarily know Morse, or they don't necessarily are able to be active in any other modes. And by a simple press of a button or triggering something, we can have a text-to-speech conversion that will help those people to be active on air.
But I can see where, everyone tends to connect on a human basis here. So if you know there's a frequency where you're going to get ChatGPT answering you, have a conversation with ChatGPT, a lot of these people just
They
it's
do.
like customer service, isn't it? If you go to a person and do it, as opposed to going to ChatGPT on the thing. I don't know what everyone
There
else
was a
feels.
station to WWBA
Mm.
who reckons he made over 400 views on a chat because he knew what his service house. That chat. When you made
Same as FTA.
Bridgeway Island was
I can argue about FT8 because that's a different story for me, slightly different story.
I can understand if like you're from a different country and you want to feel sorry with somebody speaking English, then they use the chat GPT to speak in, which will then convey it into English. And the chat GPT will be the translator and put it through. So that would be quite good.
Yeah. But it's got a beneficial use.
Yeah. Oh, absolutely.
So again, it all boils down to how we want to use the tools, right? And to some extent, I also understand that person who did that test, because if we don't experiment, we won't be able to understand where are the boundaries. We won't be able to push those boundaries, right? Even the SSB is nothing else than us trying to push the limits to make the QSOs more efficient, more sustainable, no matter what are the sunspots or whatever else, right? What power we are using. So I'm supportive of experimenting, but it might not be my cup of tea to speak to AI.
Has anyone developed anything in AI to analyze a rig? So you've got like an aerial with a certain type, you can experiment with that, and all the connections go right through to your rig. Has anyone done anything through the design, using AI?
So, yeah, so there's plenty of tools. Most of them are paid, unfortunately, but it's becoming more popular to have to have different pieces of software like M0KUK Studio, etc., that help use AI or implement AI for better modeling of the systems. There's a lot of papers that you can find and download and read that are used or you are using AI and models to model the propagation in urban areas, especially for telecoms.
I'm aware of, I might meet her actually in about a month's time. There's an Oxford University professor who's warning about the dangers of AI. And across the board on lots of things. But I can see that there's a lot of software here and there's a lot of hacking possibilities. Because
software is already done.
Sorry?
The SDR software. People have been using AI to rewrite these source codes, where
Yeah.
features that they wanted that weren't
Yeah.
right.
Yeah, so yeah, there's a lot of things that you can do with that. Coding is one thing. I think we might have some time. I did a lot of coding myself, and I see a lot of benefits also being able to get the code done for you, right? I still see the great benefit of human in the loop. So someone really understanding what's going on or what's behind the code, rather than just blindly copying and pasting, because that makes a difference. But
one thing I thought come out, I actually use screen reader, I'm a white stick operator, those that don't know, and using TTS is one thing that I'm using every day. The other thing I thought of when you was actually playing that is using STEM technology, in other words, knocking out all the interference noise. The way they've done that with the Beatles and actually brought out tracks that you couldn't actually hear properly and actually do it, that would be a great way of actually putting that into something like a single sideband and actually knocking out all the noise. Yeah.
Perfect. And that brings me to the next part. I'll try to, because I brought few other bits here with me, and one thing that I brought with me is a little bit QMX, right? It's connected to an end-fed half-wave antenna, which is just thrown on the bush behind through the window there. And I have 2 pieces of software installed there, but I will show you when I get connection to the internet here. Let's give it a try. Look, like that's something that hopefully I'll be able to do that. But while we are there, I'll still show you the software. So and let me just do one thing. Okay, so this software is called RM Noise. The way it works is relatively straightforward. So it takes input from audio, takes that input and pushes it to servers. There are multiple servers around the world. And based on multiple samples, if you want, you can contribute to that. They ask people to send them like 30 minutes of noise from their location, so that they can use those samples then to improve their models. But then you have the ability to have few different filters there. And let's see if I got connected. Seems like I am connected. Let me try again. Battery power saving mode. So we are in. So there are a few standard things that you can simply take out of the box, and you can select one of them. The trick is to select what is the input and what's the output. And the speakers should be here. And you simply activate it. what you hear right now is the output from QMX going through some servers, and seems like, yeah, the internet might not be the best here, but that's bypassed, right? So you have a lot of noise. I don't have a recording for that, but unfortunately, but you have few options to change how much of the noise reduction you implement. Yeah. With a good internet, the delay is around 100 to 200 milliseconds. So with the SSB, it's still usable. But here, with like around 1 second of a delay, it's hard. But it has a really big impact on what you hear. We can try. I'll give it a try. I'm not giving up that easily. So usually something around that amount works well. Maybe I just need to hold it a little bit higher. See? And let's try to find a station. Not quite sure if we'll be able.
Really, that's just working like some DAW software, Audacity, something like that. Doing a noise sample, reducing.
Yeah. Okay. Not necessarily the frequency, but filtering it quite well. Okay, that's not what I would like to hear. And it should be. I'm trying to find a station, but might be hard. But just to be clear, like if you try to compare that to that, there's, and it's only like 60% of reduction. Like we can even put it much more. The interesting bit is, and that's what I'm trying to effectively show here, is to find a station that we could hear. I don't want to. I don't know if I will be able to find someone. That's always a problem with demos. Sorry? 40 max. Watch out. not the best at this time of the year.
You could just say you were drunk on that.
Sorry? Sorry?
I said we'll just say you were drunk on that.
Yeah, fine. Let me try to go the other way around. And maybe we'll have... Okay, so we have some Morse here. So let's take the Morse filter and let's turn off the bypass.
You dream about it.
Like, of course, it depends on the preferences. But like I found this tool pretty good, especially if you're with speech. Like Morse has their benefits, right? But if you turn that out, one of those stations is mostly gone, right? The second one, there is a second station there. If you turn it on, you can pick it up.
In the flex radio, the RNN, you've been running on those now.
I think that they are using something else. This is a free software that you can set up for yourself. Yeah.
So since October they released it.
Yeah.
The current neural network.
Okay, I won't be messing around. But with SSB, it's probably a little bit more impressive. And you can tweak how much reduction you want. So
RM noise.
yes. The unfortunate thing is that it's Windows.
Fair enough.
Right. So if you have a Mac, sorry.
But is that working by overlaying the same thing again?
No. No. So it has some models which are trained on the samples that people send them.
Actually listening to the CW.
And it takes, or it learns to recognize the noise. So from what's coming or what is fed right now from the microphone input to my laptop, the signal is then recognized where is noise, where's no noise, and the noise is removed from it, right? Right? Rather than simply trying to shift the phase by 180 degrees. Yeah, because if you use anti-phase, you also will remove the wanted signal. And here you want to only remove the noise part of it. Right? And for me, this is one of the best use cases of like how we can practically use AI models for us. The other bit is effectively, I won't be playing right now, or maybe I can play as well as I'm connected already. Internet is not the best, but we know where we are. So I can go to why it's not writing. Shall I start writing correct way? I don't know how quick it will be to load, but effectively you can use it to multiple things, and it's not only please write me a piece of code that will blink an LED for me, right? Okay. Forget it, sorry. For this I'm prepared, so I simply do it this way and simply show you this kind of example, right? Where you basically say, please design me a filter for this band, etc. And it gives you everything there. You can also ask it to explain how it came to those calculations and what happened there and why, etc. Right? So you will receive different outputs sometimes, but there are tricks how to do it so to get slightly better results. And for the experiment that I run there, I run it against the Marquee Micro something web page, where they have, I believe, pretty good tools, simulation tools for designing LC filters, and they were there.
Probably you.
Maybe. Yeah. I would guess they did, right? But rather than me trying to find the tool, I can put it there, and it will give me the answer, the filter design, the parameters of all the capacitors, all the inductors, everything, right? So yes, the answer to your question is there are practical uses and can be done.
Very good question. Use some of these systems to develop whatever it is you're working on. Who owns the copyright or the intellectual rights?
Good question.
My answer is I don't know, right? But
you could develop the system or something, claim copyright on it.
Yeah.
AI.
You could even, as you're putting that in, you could actually say, what I'm about to put in, I claim copyright for, and I've already copyrighted it. So
yeah.
Protect your things that you're putting in.
And that brings us to the very good question, which I believe we are all behind, is that the changes on the technical side are far ahead of the legislation, right? And that's one of the reasons why I also struggle to answer that question. Okay, so I'll make a pause here. We are almost right on time. Are there any other questions?
Can I ask a piece of string question? Right, so as houses generally become smaller, our world is becoming more congested, so our land space is becoming weaker. Amateur radio is going to become harder, the noise floor is going to go up, and everything. So is AI a way of solving a problem, or is AI the problem? You know what I mean?
AI,
Is AI going to be a way forward, or is AI going to drag us down the road where it will die apart from a group of robots?
I would put it this way, because I don't have a crystal ball to answer this question. It all depends on what we will do with it, right? On one hand, it's an answer to a problem because I can use that RM noise cancelling tool. We can develop more tools that will solve some of it, right? And will allow us to bring more signal from the noise. They will also probably allow us to design better rigs going forward, more selective, more sensitive. Who knows? The physics also has limitations, right? But it will also generate new challenges that we are not aware of right now, right? The same way as like electric cars or solar panels don't create a problem on their own. Us trying to be cheap and safe on everything means that we are taking filters from where they should be, and we are generating a problem of higher noise floors. So I know that it's not yes, no answer, but I don't think that anyone has this kind of answer right now.
It's a conversation as
And we simply need to, in my head, stay on top of things and raise any concerns and be a community that shapes the future. The same way as we fought for EMC rules to be in place, the same way we can drive legislation and rules to minimize the impact of what's coming.
Something. I just brought this along. This wireless I got 30 years ago. Anyway, got an AI button on it. It says AI, it's the green one there, and what it was, it would ask, when you bought it, it would ask you loads of questions, and depending on your answers, depending on how much functionality you've got. So it'd ask you if you use repeaters, if you've done this, if you've done that. And it would mark them from 1 to 5 stars. So when I got it, I thought, stuff that you're not going to, take functionality away from me. So I gave it the answers that I knew would give me full functionality. I guess you could vote.
Yeah.
That's 30 years old, isn't it? Anyway.
Do you think AI, artificial intelligence, is the right term for the technology? I think it's actually intelligent.
Let's define intelligence, right? Or
tricky one.
It's a tricky one. I'll answer it in a slightly different manner. If a rose had a different name, would it smell differently? I know it's not a full proper quote. Sorry.
It wouldn't. The thing that slightly bothers me about the use of the term AI, the technology is incredible and it's very powerful, new level of computing, but people seem to be tied up in this idea it's AI, it's artificial intelligence. And personally, I have my doubt. I don't think it's intelligence by the standard I would judge intelligence.
That's why, but on the other hand, we like marketing, and a lot of thing behind it is marketing and money and hype, right? So it's a buzzword. Like I prefer to refer to this to machine learning because, again, what is intelligence? And whether that is intelligence. Recognizing the pattern and forecasting what is the next in the queue, is that intelligence?
It's being used by government. I mean, there is AI winters, but this time an AI winter, yeah, there might be finance to with a market crash. But I do know that governments are propping this up. SSDs alone have trebled in prices last summer. And if you speak to doctors, professors that tell you that they get very frustrated in the health side because all the money's being used for IDs, CBDCs, and building data centers, and it's all this AI stuff. So it's skewing everything.
Yeah.
You know, not for good purpose. So,
yeah, unfortunately.
Well, it's AI. They're on time.
Yeah, that's fine.
Thank you.
Thanks a lot. Many thanks for inviting me, and I hope that you liked that little talk.
We like the biscuits as well.
Great. Thank you.
Give them a biscuit, they're happy.